My name is John Murray. I'm a product manager here at Google Cloud. And I work on what used to be called the Cloud Services Platform. We didn't change the session, but we did change the name on Tuesday. So it's now called Anthos. And I'm going to talk a little bit today about policy management for that. So I'm going to go through some of the tools that we have in the open source software that we're shipping that allows you to manage corporate policies, governance policies, and those sorts of things on top of Anthos, as well as talk about some of the tooling we built on top of that open source to make that easier, particularly when you're running a hybrid or multi-cloud environment where you've got a lot of distributed compute out there. So let's get started. For those who did not see the announcement on Tuesday, Anthos is our application modernization platform for the hybrid multi-cloud world. And the idea here is that we have services, a marketplace, and a control plane that lives in the cloud here on GCP and is a central place for you to manage all that stuff. And that fans out to a bunch of different compute environments, either, say, running on GCP, running on-prem with GKE on-prem, or other clouds. The basis of that are a number of building blocks. And so it starts kind of at the bottom with the infrastructure operator. So I've got kind of that role here as somebody working on Google Cloud, but that could be infrastructure that's in any kind of environment, right? It could be another cloud, could be on-prem. And so that's stuff like storage and networking, VMs, and other kind of primitive building blocks of infrastructure. And that's the foundation of Anthos. On top of that, we have a Kubernetes distribution, so GKE on the cloud, GKE on-prem. And that allows you to have kind of a uniform computing layer with a uniform API across all of these environments. And that's kind of the first level where policies come into play and where you can start controlling that environment. And then above that, one of the other layers that we have is Istio, which is our service mesh in open source, but also something that we manage on GKE and that we're building tooling around, such as the Cloud Services Mesh, which is in alpha right now. And that really allows you to think about your services kind of at the HTTP L7 layer, abstract those out, and think about a traffic as a graph in a kind of microservices environment. There's a number of policies there that have to do with how services talk to one another, how traffic is routed, and we'll get into that in a little bit. There are many other pieces of Anthos here that you can bring to the table. I'm going to talk mostly about these, but we have things like Cloud Run and Knative for running sort of serverless containers, although the servers are still there, as many of you know, and things like our marketplace, various other bits and pieces. In addition to that, I'm going to talk today about Anthos config management. So that is a way to knit all of this stuff together and provide you with kind of a single administrative experience for talking to all these different platforms in a kind of distributed environment. And the way that that works is that we use the Kubernetes native policy formats, which effectively are putting all of those policies in code so that you can analyze them, so that they're repeatable, and so that the policies that you apply to this environment are auditable, reproducible, transactional, and self-healing. What I mean by that is if you put all of this stuff in a Git repository, you get a lot of the advantages of source control. So you can go and look at everything in one place. The changes that you make to a particular cluster or the multi-cluster environment are reproducible across new clusters that you bring in or new service meshes that you bring in. A Git repository is transactional, so that when you make a commit, you can roll that back. You can roll it forward. You know exactly what was changed by when and by whom. And then the self-healing aspects of this are that we are looking at these Git repositories, bringing down the configuration all these different places, and then constantly reconciling that in the local environments to make sure that if things drift out of line, that we bring them back in. And I'll talk a little bit more about that. So let's talk about the policies that are available to you. The idea with Anthos is for us mainly to work off of open source. So there's a lot of open source stuff that you can do on these platforms, as well as a lot of stuff that we can do inside the infrastructure. So to the degree that we've needed our customers to operate on these platforms, we've gone into the upstream open source and tried to contribute to some of these things alongside many of the other folks who work on the platforms. For Kubernetes, that means things like access control. So Kubernetes has a role-based access control system that allows you to define who's allowed to do what on any given cluster, who can deploy pods, who can make changes to policies. Networking, there is a number of different networking mechanisms in there, things like network policy, which allow you to define routing between individual pods on a cluster. And we support that in GKE as well as on-prem now with our partners at Tigera, who make the container networking interface for Calico. And then security and isolation. So you can do things like set up a pod security policy in Kubernetes that allows you to define what a container is allowed to do in terms of interacting with the host environment. And that creates isolation through things like namespaces, as well as isolating the containers from kind of the underlying environment to ensure that they only have the access that they need and they're not able to kind of break out of that and move across boundaries. On the Istio side, one of the great policies there is traffic routing, right? So Istio is something that you can use to think about your services at kind of the level of the inbound traffic that you have. You set up a gateway and bring in your ingress traffic, and then route that to microservices using things like waiting, setting up things like mutual TLS so that all of the different services within your service mesh are communicating in an encrypted fashion. And you can do things like service-to-service access control. And so if you have a flat network where everything is talking to one another, that might be fine, but it might mean that an attacker can, compromise one of your services and go look at something that they're not supposed to be. So service-to-service access control is a way to ensure that only services that should be talking to other services are sending traffic around. And then there's a whole bunch of extensibility in Istio. So there's a mixer component in there that allows people to bring in plugins. And so you can do things like plug in telemetry, but you can also do things like plug in authorization. And there's a number of different things in the community that we support there. And then when we talk about the infrastructure, we're really talking about kind of the underlying stuff. So on GCP, that's stuff like GCP services. So you may have your clusters backed by storage that's sitting on a GCS bucket. Or you may have your services backed by a SQL database like Cloud SQL. Things like firewalls, secure images, and even the cluster flags that are on your cluster. And so we want all of this stuff to be able to be declarative. And what I mean by that is you can show up and tell us exactly how you want this environment to look. You can put constraints around that to say, these are the types of things that we want our developers or our administrators to be able to do. And then enforce all of that in code, just like you enforce things when you build applications. And so shift some of that compliance further up into the infrastructure pipeline, and then give you the tooling to kind of make that a lot easier to manage. So I talked a little bit about API server flags. That's a really important piece of security on Kubernetes. There's a lot of things that you can set up a cluster to do that are relatively insecure. And so it's not sufficient just to come in and change the configuration on top of your cluster. You often have to think about the configuration of the cluster itself. One of the advantages we have at GKE on-prem and that Kubernetes distribution is that those clusters are built declaratively. And so you're able to specify a cluster actually as a Kubernetes object with all of those flags set. And so you have a reproducible way of stamping out clusters that's secure, and you can validate that by looking at the code. Access control I mentioned already. RBAC is, I think, the best and most widely used way of managing that on Kubernetes, but there are a number of other ways you can manage access control. Network policy I mentioned. Resource quota is a way to set up policies about who can do what in terms of resource consumption. So CPU, memory, number of processes running, that sort of thing. And that's a great tool if you have kind of multi-cluster environments, multi-tenant environments. We've got a lot of people sharing one cluster. You don't want noisy neighbors. You want to keep people isolated and ensure that they're only using the resources that are allocated to them. Admission control, I'll talk a little bit about later as well, but that's a point of extensibility within Kubernetes that allows you to look at the inbound traffic on the API server and enact custom rules against it. So you can do things like to bring your business rules in. If they're not handled by some of these other built-in policies, then you can enforce them yourself. And finally, pod security policies, which allows you to kind of define what things are allowed to do vis-a-vis the host system. And there's a number of kind of levers and dials there. For Istio, the policies are really about defining what you can do in terms of service-to-service routing. So Istio, what it does is injects an Envoy proxy as a sidecar to all of your services that are running, and then it uses that mesh of proxies to enforce policies as well as collect telemetry. And so there's a number of adapters, as I said there, that allow you to do things like push your telemetry out to Prometheus and Grafana or Stackdriver on Google Cloud. And then you can do other things like connect with Apogee APIs over gRPC and enforce policy there. And those sidecars also are able to pick up policies directly from the clusters which Istio is running on. So you can do things like enforce mutual TLS, which is a great thing to do. It means that if somebody's in and able to sniff your traffic, it's all encrypted. Service-to-service authorization allows you to do routing and rollouts. And so you can shape your traffic, you can move it, you can do kind of blue-green deployments, all through a top-level set of rules. And then you've got fine-grained gRPC controls if you're doing gRPCs in between your services. So infrastructure, there's a number of interesting ways you can kind of provision your infrastructure as code. I mentioned GK on-prem. Those clusters, including kind of the CIDR ranges that they have on-prem, the API flags that you're setting, that's all declarative. So you can specify that once. You can stamp out clusters that are all doing things according to what you'd like. It is not a scenario where you have to have somebody running a command line tool and having multiple developers doing whatever they want. As an administrator, it's something you can keep control of. And that GK on-prem API as well is able to control the underlying machines. And so it kind of abstracts away the VMs and allows you to do things like rolling updates of the infrastructure. So you can do a node upgrade, scale a cluster, all through a code interface. We're taking some of that declarative stuff and bringing it to GCP as well in a Kubernetes environment. So we have a number of GKE customers who need to use the underlying kind of storage resources, for example, on GCP from their Kubernetes cluster. Today, if you've got something that's backed by a GCP service, you've got to kind of go outside of Kubernetes and go into the GCP APIs to do the provisioning of that infrastructure. We've announced a GCP Cloud Connector in Alpha, which is a way for you to do that directly from the Kubernetes API. And so that doesn't have full coverage of our API surface today, but what it does allow you to do is manage some of the resources I've got listed here, so that you can create those things as Kubernetes objects. So when you're doing a deployment of an application that's backed by, say, Cloud Spanner, you can come in and not only do the deployment directly against the Kubernetes API, but you can say, I also want a Spanner database to be deployed alongside this. And that's defined as a Kubernetes resource. We use what's called custom resource definitions, which is extensibility built into the Kubernetes API. And that allows you to define these things at that layer. And so if you're coming in to Anthos and you want to do that, you can manage all of that as a set of Kubernetes resources. So that's kind of the set of things you're able to do with the stuff that's shipping with Anthos. That doesn't necessarily mean that it's easy to manage a hybrid kind of multi-cloud setup. So I want to talk a little bit about dealing with scale, how you can scale up from maybe a small footprint into having something that runs across a large tech organization where you have multiple teams of administrators potentially, lots and lots of developers, all working in a fairly fractured hybrid environment, and some of the tools we're building to make that a little bit easier on folks. So this is kind of a journey that I see a lot of people go through when they start with Kubernetes, they start with GKE, is that when you're evaluating something, you've got one operator, one set of policies, and one cluster. That's kind of step one. And it's fairly easy then to just take your policy set and run a command line tool like kubectl that pushes policies to the cluster, and you can keep those on your local hard drive, and because it's you and your cluster, everything's fine. You understand everything that's going on, you're the only person who has to care. But quickly it gets a little bit more complicated. When you bring in a team of operators, when you have multiple people who are responsible for managing a Kubernetes environment, you can't just have a local set of files, and you can't just have people pushing them necessarily from their command line because you can step on each other's toes. One person might be writing over somebody else's stuff, and so that's where we think a repository is a really useful tool. Source control mechanisms were built specifically for this use case where people need to collaborate on code, and you can do things like use the tooling that's built around them to do code reviews, to do static analysis of that code, and to understand who did what, when, to roll those things back, et cetera. So there's been decades of work on repositories. That's a solved problem for collaborating on code, and we want to use that for infrastructure as well. But it gets even more complicated when you have these sort of multi-platform environments. So if you're running on GCP, you're running on-prem, you're running in another cloud, now you have to deal not only with collaborating with a bunch of people in a repository, you have to deal with getting that repository and its declarations out to all those clusters so that the policies that you've written are actually applied. And that's a non-trivial problem. You can loop through these things and push the policies, but if that fails, you're halfway through that, and now you've got one set of policies in one place, another set of policies in another. These are distributed environments, so people can come in locally and make changes. Even if you do your best to keep them out of that and keep them through this channel, it's always possible for something to go down, something accidental to happen. So if you're not aware of that, or you're not able to reconcile that, you may have something that's out of scope or out of policy, and you don't even know about it. So dealing with the collaboration aspects and the distribution aspects is something that we wanted to build tooling around to help folks out. I'll quickly talk about why you might want to have a bunch of different clusters, why you might end up in this scenario. There are a ton of reasons, and they often tend to be driven by the nature of your business or the vertical that you're in. These are some of the things that we see. So obviously, everybody who's been operating for a while has legacy software. You might have an ERP system, you might have a catalog database that's sitting on-prem, but you want to do stuff in the cloud, so you're building your new site in the cloud. You've got to have compute in both environments because of data gravity or things that just don't make sense to lift and shift over. You may want local execution. So it's not always possible to do everything in the cloud, particularly if you're dealing with tons of data. If you've got a factory floor or a warehouse with IoT stuff running around, you probably don't want to ship up every little last bit of data up into the cloud, and you might want compute running locally. Jurisdictional issues. So if you're a global operator, you're going to have the need to deal with laws all over the place that have to deal with data sovereignty, keeping things that are generated in one place stored in that place. Augmenting services, you may have a bunch of stuff that's running on-prem, but you want to take advantage of some of the great machine learning tools that they have in the cloud, and so you've got to get data up there. IoT, we're running into a number of retailers who run Kubernetes clusters in every store for things like point of sale systems or telemetry from various sensors. And then bursting, right? So you've got things running on-prem, but you want to be able to have flexible capacity using the cloud. So you may have all of these things driving you, and where that leads you is that you end up with a fairly fractured environment, and you need some kind of glue to bring it back together. Not only that, but you've got to deal with compliance. So you've got an environment that's growing in complexity, and then you've got an outside environment that's has ever increasing concerns about governance. So that's things like the alphabet soup of compliance, the GDPRs and the HIPAAs and the SOX. It's things like government regulations. It's also things like business processes and security needs. Those are getting more and more in terms of the number of them. They are getting more complicated, and the complexity of your environment is just making that worse and worse over time. And so we see that, and we think an important solution to that is really thinking about policy as code. Right, taking the various policies that you have and turning them into code so that you can rein in a little bit of that complexity and start using compute to deal with it. And so policies code is a pretty simple idea. It's basically the ability to take everything that you care about as an administrator, codify it, and then start running your business processes and your business rules on top of that. Anthos config management is a tool designed to help with that kind of principle. And so we've got a multi-cluster kind of architecture. It scales to hundreds of clusters, even thousands of clusters, because the repository is really the central piece of it. And so anytime you bring up a new cluster, if you've got Anthos config management installed on it, it connects to the central repository, can pull down the policies that apply to that particular cluster. And that means that we run fairly distributed. And so if you have a cluster in every retail store, that's an environment that we can support. It works on-prem and in the cloud. There's nothing about the service that requires you to talk to GCP. We are going to build ways of pulling in telemetry, ways of managing it through the cloud, but it can run entirely disconnected on-prem. So you can keep your repository on-prem, you can have your clusters on-prem. If you're running with Anthos, you don't necessarily have to talk back to the cloud to get in touch with your repo or pull down your configurations. It is declarative and continuous. So by declarative, what I mean is you put your policies in there as you expect them to be applied. You don't have to wait for them to be applied. You just tell the system what you want, and that's kind of the Kubernetes way. And then we take that declaration, we apply it to all the different API servers, and then run in a continuous loop to ensure that the system is brought in line with that. So that reconciliation is a constant process. And what it allows you to do is define once how things should be, and then hand that off to the controllers that are running in the various clusters to ensure that things are happening that way. And then migrating to it is fairly simple because we are using the same format for these policy definitions as Kubernetes. It is an open format. It's the format that people are used to managing clusters. If you're managing clusters today or you're managing Istio today, you can take your configurations, cut and paste them in, and it should work. How that looks is that we just use Git as a source of truth. And so our repository is more or less a set of YAML files that are expressing all of your policies with some, a little bit of massaging to ensure that the policies that need to go to one place or another are handled. And so it handles all your Kubernetes and Istio resources, integrates with your source control. Everything is native YAML. And we can plug our validators into kind of whatever source control system you're using and run kind of inside the same workflow that you have for your code. It's all meant to be kind of pluggable and extensible. So you can see on the right here, I've got a directory structure of a repository. I'm putting all of my stuff in namespaces. I've got quota. I've got role bindings. And it looks very much like a repository you might set up for yourself if you were just applying these things with kubectl. So I'll get more into that when we go into the demo, but that's kind of the basic structure of it. So how that looks inside of a kind of sample architecture for a hybrid Anthos deployment is that you might have a policy repository that's sitting in an on-prem data center. And you can put all of your Kubernetes definitions that you need as an administrator there. So things like access control, things like network policy, pod security policy, et cetera. Things like your Istio mesh enforcing mutual TLS. That can all go into that policy store. And then you may be running clusters in the Google Cloud Platform. You may be running clusters on-prem. As long as you have interconnect set up so that that looks like a one routable network, everything can come back and talk to the policy repository, and all of the clusters that you've got running in both environments are able to see those and pull their stuff down. If that interconnect goes down, we keep the last state. We continue to enforce those policies. And so any network interruption between those environments just means that new changes aren't able to come across, but the last good state is still there and is still being enforced. And you can see kind of we have our config management operator in both places. That's the system, the distributed system that's running on those clusters and making sure that everything is in line. And the fact that it is kind of a distributed system means that, again, if there's a networking outage, those processes are still running. And so what this enables you to do is have defense in depth for the policies that you really care about. And it's really kind of a shift left sort of mentality for administrative policies. So the flow here, when you're making changes, once you have stuff stored in a Git repository, is that anything you want to do, you cut a branch for it. And that's humans cutting a branch. So say you've got an administrator who wants to add a new namespace for a development team, cut a branch, add that there, do a code review on it, and push it down. But you can also have machine processes, algorithms that are doing the same thing. So if we can do static analysis on all of your policies, we can make recommendations. One of the things we announced here is our policy intelligence stuff that we're doing on Google Cloud that's doing analysis of IAM to look at things like overgranting. Once we're able to see those things, we can translate them back into changes. If we know your current state in code, we know how we think it should be, we can send you a pull request. And so there's a whole set of stuff that you can do once you're able to do static analysis on your policies. We're just getting started in that area, but I think it's a really promising avenue once we can get folks to start doing stuff in code. Once you've got those changes, you can validate them. And so you can put all of your business rules, at least those business rules that you're able to codify, into validation. So we ship with validation that looks at syntax and the correctness of the repository to ensure that bad configs, malformed configs are not coming down. But as we continue to develop on top of this, we're going to ship more and more validation to allow you to do things like bring pluggable business rules. And what that means is that if somebody's in violation of your corporate policies or they're doing something that they shouldn't be doing in terms of changing network routing or changing access controls, you can catch that in the pipeline before it hits your environment, before it goes out to your clusters. And so you can shift kind of from grabbing those things and auditing every so often to understanding that this is a bad config up front and we're not going to allow you to push that because we're running, say, a GitHub check on it that lets us know that this policy is outside of the guardrails that administrators have set for it. It's going through code review as well, right? So teams of administrators now can collaborate. You can kind of have two people who have to turn the key on major policies. You can see who reviewed it. You can make changes. You can do all of that before it hits the production environment. And then you can also enforce things at the deployment stage. So admission control to block things from the clusters. You can use the same logic in validation against the API. So even if something comes through this process, you can stop it from hitting the API and stop us from syncing it. Reconciliation and auditing still allow you to kind of guard against drift on those clusters. So if somebody comes in and makes a local change that's out of spec, you can come in and overwrite that kind of immediately. Instead, I talk about admission control here. So another project that we're working on in open source is called Gatekeeper. Gatekeeper is an admission controller that we are planning on including and helping folks manage in concert with a lot of this stuff. The key thing about Gatekeepers and admission controllers is that it uses the Open Policy Agent, which is a CNCF project. And Open Policy Agent is effectively a policy evaluation engine. It takes a set of policies expressed in code that anybody can write and will enforce them wherever it goes. So what Gatekeeper does is wrap that in the kind of infrastructure it needs to be run as an admission controller, and then allows you to define as a Kubernetes resource any policy you want to be evaluated against things that are going to hit the API server. So an example of that might be label enforcement on deployments. If you need all of your deployments to have particular labels, or you need them to have a label, you can say, look, if you're going to deploy and you're going to deploy this kind of image, it needs to have this particular label, or we're not going to accept it. And those label rules may be specific to you, and you can kind of program them in there. So Gatekeeper comes with a kind of Kubernetes interface to push standard rules, but it also has a programming language that allows you to write those yourself. So let's jump into a demo here. I'll show you a little bit about how we run. Just give me a second to log into my machine. Okay, can we bring up the demo? So what I'm going to do here is show you just a simple deployment of an Istio application. It's called the book info application. It's the kind of demo Istio thing. You may have seen it a few places on the floor here. It's available in the Istio docs as an example. I'm just going to play around with some of the policies here, show you what that looks like in a code repository, make a couple changes, and we'll go look at that live. So what I have here is a tmux session. On the left is where I'm going to be running all my commands. It's all scripted, but it's all running live. On the right, I've got my local file system. So I have a copy of a repository that I'm hosting up in GitHub there. And at the bottom, I've got a couple of watches. And those watches are on live clusters running on GKE. I'm running on 2, but everything I'm doing here, you could run on thousands of clusters if you wanted to. We've got a watch here just looking at some pods, so you'll be able to see them coming up as I'm making changes in the repository. So I'm going to set my kubectl to look at a particular cluster. And I'm going to bring in all of the policies that I need for my application. So this is the local file system here. This is our repository format for CSP config management. Sorry, Anthos config management. We've got clusters, cluster scoped resources at the top. So I've got a pod security policy in there that's ensuring that my deployments are only able to do certain things against the host environment. I've got a cluster role there for service deployers that allows me to define on a namespace per namespace level who should be allowed to deploy within that namespace. So that's something that I can hand out to individual groups of users or individual users. And then I have all my namespace level resources. So this is where all of the deployments are defined. I've got 2 namespaces here, miscellaneous and services. And then I have an admin role binding that I want to apply across both of them. And you notice that admin role binding sits in the directory structure above both of those namespaces. What we allow in our repository format is kind of copy down inheritance. So if you have a resource that you want to be spread across multiple namespaces, we can use the hierarchy of the directory structure to kind of inherit that down. We can also apply to a group of namespaces. So if you don't have a hierarchy and you want to just use sets of namespaces to apply policies, we have a mechanism for that. In addition, you can apply policies to individual clusters or individual sets of clusters based on label selection. So this allows you to say, okay, I have one set of policies that need to be everywhere, or I have some policies that just need to be in these namespaces or just these clusters, or some combination thereof. I've got all my services for the book info app here in the services namespace. And then I've got a miscellaneous namespace up there that just has a namespace definition and a quota attached to it right now. So it's empty, there's nothing running there. So let's go look at what we've got here. So I'm going to add this to my repository. You can see nothing's running at the moment. This is all local. It's just a set of policies in my file system. I'm going to make a commit up to my Git repository and add all of these files and push that live. So this is going up to GitHub, pushing all of those policies there and updating the repository. And then I've got the clusters watching that. And you can see already I've got pods initializing on cluster 2. Cluster 1's a little bit behind, but it's catching up. And so now I've got all of the services that I need for my microservices application to run. I can go take a look at the cluster. So I'm going to go look at the role bindings in the miscellaneous namespace. So as you can see, there's no role binding applied directly to that namespace. All it's getting is an inherited role binding from the directory above it. But if you look at it live on the cluster, there's that admin role binding that showed up 35 seconds ago. And so this is great for things like administrative role bindings, this inheritance, and that you can set that once and apply it and make sure that every single one of your namespaces in kind of a multi-tenant cluster has access for your administrators. It's not just for role bindings, so you can also do things like apply a network policy. So if you have the requirement that you want everybody to be strictly defining pod-to-pod traffic, so they say this service is only allowed to talk to that service, you can put an empty network policy at the root of your repository and have it inherited down to all of your namespaces. What that'll do is, by default, cut off all traffic outside of the namespace, and it'll force your developers to come in and define it explicitly on top of that. So there's different ways that you can use that to kind of simplify your policy application, not have to be repetitive and doing things namespace by namespace. One of the other nice things we do is guard against people coming in and doing destructive things against administrative policies. So that's an admin role binding. If I'm an administrator, I probably want that there. I need to be able to get in there. If somebody came in and decided that they were going to delete my SRE admin role binding from their namespace so they could lock out the admins, that would be bad. I've got administrative access on this cluster, so I can go do that. So let's go do something destructive. Let's delete that role binding. So now, my SREs can't get back in, but if we go look at it on the cluster, you can see it's back. 7 seconds ago, which is just about when I applied it, we came back in and rewrote it. And so if you come in and you try to affect one of these policies that the administrator has applied, we can automatically reconcile that back to whatever's in the repository. So let's go look at the quota in the miscellaneous namespace. So this is resource quota that I'm applying here. So in this namespace, I put in a policy that says you can only have one pod, you can only use 10% of a virtual CPU, it only gets 100 megs of memory. If I want to say deploy a pod here, I can do that as long as I'm within that quota. I'm going to deploy, it's kind of cut off on the left there, but it is a instance of BusyBox that sleeps. This is not a particularly useful thing to deploy in your clusters, but just for an example. You can notice, if you see just at the top there, I'm deploying a pod, but I happen to have misspelled it. It says PD instead of pod up on the left. So this won't work if I try to push it to the cluster. If I put it in the repository, it'll never get synced down. I'm just writing it locally, so that's not a problem yet. As I said, one of the things we ship with is a validation. So we have a command line tool we call Nomos. This can run as a Git hook. It can run as a check, say in GitHub or some other source tooling system, so that every time you push something into the repository, you can validate that it's syntactically correct, that it's correct based on the format of the repository, and that you're not going to be trying to push bad configs. If I run that against this pod definition, it throws an error. Lets me know no matches for kind PUD in version v1. So let's go fix that. I'm going to come in here and add my missing O, and then save it. And so if I run that validation again, it passes clean with no errors. So now I'm ready to go, and that's a clean pod. So let's go take a look at the running services here. I'm going to figure out where my service is actually running here by looking at the gateway to Istio. I'm going to pick this up, and we can go look at it. You see, this is the GitHub repository where I'm running right now. If I refresh that, you can see all of the resources that I got here. So let's go look at our Istio service. No, doesn't look like it's running. Seems like I've got a networking problem here. All right. Try one more thing. So it looks like my pods are running, but it is not routable. Not sure if that's my local networking causing problems or not. All right, well, we'll move on. We've got running pods, but we've got no network connectivity. So one of the things I can do with this is change some of the routing rules in my microservices mesh. So the Istio allows you to define what we call virtual services. Virtual services can take traffic that's coming in through the gateway and route it into individual pods. I've got virtual services defined here for the various things that are running in my microservices architecture. And if you look, you can see I've got a reviews service here that's routing 100% of my traffic to the V1 pod of reviews. There are actually 3 different versions of reviews running on each of these clusters. So if I want, I can do an upgrade in place by routing the traffic from V1 to V2 because those are running. Now in a real life environment, I probably would do this very slowly, right? I would take it and I would maybe have a canary branch where I had a cluster that was pointing at a canary branch of my policies, make that change in the canary branch, go take a look at it live, make sure it was working. I may decide to route just a very small percentage of traffic there, go look at my monitoring, and make sure that that was working. You can do all of that directly through this kind of code-based interface. But since we're short on time, let's just do it live in production. So I'm going to upgrade this to V2. And I'm going to save it. And that's all I need to do to upgrade that service. Now what that does is it changes to a new version of reviews that actually calls the ratings system. So it's going to bring in additional information to the book info app. And we can make that change and push it up. Okay. So that's gone out to GitHub. And now if we look at the live cluster, it's still looking at V1, but it just flipped over. So you can see where it says subset down there. Now it's pointing at V2. So we've changed our routing rules live on all of our clusters. If I go look at this other cluster, hopefully my service came up there. So let's see that one and see if it's live. Okay, 1 out of 2 ain't bad. So this is my other cluster. If you had seen it before when it was working on cluster 1, you would have seen that there were no star ratings. There are star ratings now because I've upgraded that version of the microservice. And it is pulling from the rating service because of the routing rules I've changed. And these routing rules have changed on both those clusters simultaneously. If I were to enroll 10 clusters or 20 clusters, I could make that change across all of them, or I could make that change across a subset of them, depending on kind of what I want to do there. One other good thing about having a Git repository is that it's transactional. So everything that I've done here was done in a particular commit. And I can roll those back at any time. If I want to undo all of my changes and get back to a clean state that I know is okay, I can just delete everything I added locally in my environment and then push it back up to the cluster. And so effectively what that does is reverts all of the commits that I made, removes all the files that I added, and goes back to the state that we were at when we started the demo. And if I push that up, it's going to clean everything out that I built. It's going to clean out all of those routing rules. It's going to clean out all of these pods. It's going to restore my state back to where I wanted it. And if we look, we should see those pods start to terminate. And there they go. And so this is going to roll everything back, bring it back to an entirely clean state where I've got naked clusters. So that is my demo. Can we go back to the slides, please? So that's CSP config management, Anthos config management. I'll get used to that eventually. If you're interested, it's available now to Anthos customers. So if you were participating in the Anthos beta, or you're signing up for Anthos, this comes along with it. It works on-prem today, it works in the cloud today. If you're interested in getting early access because you're a GKE customer, we are gonna make it available to GKE customers. And so you can sign up here if you're interested in that, and I'll whitelist you for that and bring you in. We do expect to make it available on GKE as well for folks who are kind of purely cloud-based and working with us in GCP. We're out of time. I'll hang out if folks want to talk. Thank you very much.